So today's topic is component level design. Okay. So this is modeling the component level design. Okay. So now this phase basically occurs after the architectural design. So our previous video lecture speaks about that. And here we try to focus on the detailed design of the software components. Okay. So basically this phase occurs after the architectural design. So now it focuses on the detailed design of software components, right? So this is what modeling the component level design. So let us see what is component level design. So component level design translates the high level software architecture into detailed design for each module or component that will be coded. So a component is a modular, deployable, and replaceable part of a system that encapsulates implementation and exposes a set of interfaces. Right? So now each class is fully defined. Sorry. So now here you can see the three things which are mentioned here by which it is illustrated. That is modular, which is self-contained, deployable, can be distributed and executed independently, replaceable, that is can be swapped with another component without breaking the system, right? This is modeling the component level design. Then next we move on to views of the component. So views of component, we have three kind of views. Okay. First one is object oriented view we call. So what is object oriented view? A component is a collection of collaborating classes. So each class is fully defined with attributes as data members, operations as methods or functions, interfaces, that is how it communicates with others. So, to elaborate this process, we further define each attribute, operation, and interface, and we design the appropriate data structure for the attributes, and also we design the algorithm for the operations, and we design messaging and interaction mechanism for communication. Okay, let me specify this. We we define each attribute. We define each attribute, operation, and interface, and then we design appropriate data structures for the attributes. Okay, that is your data members, and then we design the algorithms for what? For various operations, right? Then we design some messaging and interaction mechanisms for communication, right? That is about object oriented view. Next, second view is conventional view. This is where a component is viewed as a functional module. This contains processing logic, has the internal data structures, and offers an interface for communication. So what is the role of the components here? So first one is control component, where this manages the flow of control in the system. Second is problem domain component. this will implement customer required functionality. Then infrastructure component, third one is which provides a supportive system level functions. Okay. So generally we can derive this from your data flow diagrams, where the lower level DFD bubbles, that is your software modules, components are arranged in hierarchical structure, right? Where the control components near the top and problem and infrastructure components the lower down in such a way. So the design steps are, we define the interface, right? So we define the interface, that is number or order of parameters, we say, and we define the data structure used, all right, and we design the algorithms. That means typically with stepwise refinement. So these are the design steps. Okay. Third one is process related view. Third view is process related view, which focuses on reusing pre-built components from a component library that which exists. Whichever is having high relevance with this, it will be used. This will promote the reuse rather than building everything from the scratch. So each library component includes interface specification and description of the function it performs and required interactions with other components. Okay. So basically, the principle of not to reinvent the wheel, we basically try to make use of the pre-existing components from the library. Okay. Such that what happens, we can not write the code from the scratch, or we can also say that using the pre-existing or the components which are existing will improve this reusability concept and also saves the time of the developers. Then designing class-based components, that is object-oriented design principles. So first one is open closed principle. Here it says that components should be open for extension but closed for modification. This is what open closed principle says. Second one is Liskov substitution principle. What it says is subclasses must be interchangeable with their parent classes without altering the behavior. Third point says dependency inversion principle. That is, depend on abstraction, that is interfaces, but not on concrete classes. Fourth point is interface segregation principle, where it creates small specific interfaces instead of one large or general purpose interface. Then component packaging principles. First one is release reuse equivalency principle. That is, the unit of reuse should also be the unit of release. Second point is common closure principle, where group classes that change together into the same package. Third point, common reuse principle. That is, only group classes that are reused together to avoid unnecessary updates and retesting. Thank you, students. Hope you understood.